Good morning, students. So, after learning the identification of the elements of the matrix, and then also we have learned in our second episode, that is types of matrix, and these types of matrix I had done in two part 1 and part 2. Today we would like to teach you the product of matrix. Now, what we have covered up till now? We have covered up till now identification of elements of matrix, and number 2 we have learned the types of matrix, different types of matrix. And today we would like to learn the product of matrix. What is the product of the matrix? In algebraic operations we have done, say x and y, xy, x square and y. Similarly, if I am given two matrix A and matrix B, then if I multiply these two matrix, then it is called the product of matrix. So this, if A is a matrix and B is another matrix, then if their matrix is possible, then A cross B or A dot B, AB, this is called the product of the matrix. Product of matrix. Here, the left matrix A and the right matrix B is very, very important. This matrix which is occupying in the left side, similarly, you know that because AB matrix and BA is another matrix, this is also product of the matrix. And definitely, these two products may not be same. That I will tell you later on. But these two products may be same, may not be same. And this will differ from our general algebraic type, because 2 into 3 in algebra, 2 into 3 is equal to 6, and 3 into 2, that is commutative, 3 into 2 is also equal to 6. But in matrix, AB and BA may not be same or may not be equal. That's why the position of the matrix are very, very important. If in AB product, matrix A, that is left part, is known as prefactor matrix. Prefactor, or you can say pre-multiplier matrix. And B is known as post factor or post multiplier matrix. Prefactor and post factor. In this way, these two matrices are being multiplied. Now, once you understand prefactor and post factor, now we have to say that all the matrices we cannot multiply. There are certain matrices that we can multiply, but each and every matrices cannot be multiplied like algebra. In algebra, I can multiply anything. Suppose 2x square into 3xy. You can, if I write 2x square into 3xy, I can multiply. And the same result also I can get if I multiply 3xy into 2x square. But here, this will differ. That's why we have to learn it very cautiously. First of all, let us know first that under what condition to multiply two factors, these two factors, prefactor and post factor, can be multiplied. See, in the prefactor, that is, if A and B are two matrices, and if I want to know the product AB, then I have to know what is the order of the matrix A and what is the order of the matrix B. The order of the matrix, if I tell you, suppose m into n. M into n means what? M into N means this matrix A is consisting of M number of rows and N number of columns. Then matrix B, if I multiply this, there is post factor or post multiplier. This, for this matrix, these rows must be same. These more rows must be same with the prefactors column, that is N. So row number of rows in post factor must be equal to number of rows in the prefactor matrix. This N has to be same, and that's the column can be anything. It can be N into P. So if I multiply this, we can say that as if you cancel this N, you can get AB product, and that order will come the M by P, that is M number of rows of 8th matrix and P columns, that is column of the post factor or B. So this is the order for the product of the matrix. So what we get, that if the order is M into N for the matrix A, that is prefactor, and if the order of the matrix B is N into N cross P, then after the product, the result matrix, that order will be N by P. That is, suppose, I can give one example. Suppose a matrix order is 2 by 3. Another matrix, a rectangular matrix, another matrix, a post multiplier matrix. This matrix, suppose it is 3 by 4. So after the product, whatever the matrix, that is AB matrix, for this AB matrix, what will be the order? The order will be 2 by 4. I hope you understood the first concept, very, very important concept that we have to learn. Once we have learned, so I write over here that column of prefactor should be equal to rows, number of rows of prefactor matrix must be equal to number of rows of the post factor matrix. This has to be same. Our next case is, it is important in the matrix, that is how to multiply this. Number 2 concept. So concept number 2 is you multiply the matrix. Suppose it's a matrix 2, 3, 5, 3, 5, 6. It's a matrix order 2 by 3. If I want to multiply this, suppose, and that has to be 3, 5, 2, because here the number of rows must be 3. 2, 3, 6. This is a matrix that is 3 by 2. Can I multiply this? Definitely I can multiply. And after the product, the result, whatever I will get over here, that has to be, if I cancel this, 2 by 2 matrix. 2 by 2 matrix. This 3 3 cancel as it, and you can get 2 2 matrix. This is the first rule. Second concept is that how we multiply this. That is very important. How we multiply these 2 matrices. These 2 matrices, whenever you are multiplying, concept number 2, we have to follow this logic. That is row wise, we have to multiply row wise and column wise. If I want to multiply first row, I will multiply the first column. I am here giving you a very easy concept that how, so that you will not forget that how you will multiply this. You write the result over here. Here 2 by 2 matrix. The product result I can write in this way. P11, P12. Write in this way. It will help you. P21 and P22. Write this scheme. If you write this scheme, you will never forget that how I will multiply from here. Because this will tell me how you will add. P11 means what? P11 means I will choose the first row of the prefactor and first row of the post factor, that is 352, and I will add these elements. That is, if I multiply this and this will help me. This scheme, if you write before every multiplication, you write this scheme. This will help you to get the result. So if I multiply this, 2 into 3, 6, then you have to add each element. Plus 3 into 5, 15, plus 5 into 10, 10. This is your P11 matrix. What is your P12 matrix? Very simple. First row and second column. That is first row and second column. Here what I can get? Here I can get P12, matlab 2 into 2, 4, plus 3 into 3, 9, plus 5 into 6, 30. So in this way we can get the P12. Next is P21. P21 matlab second row and first column. Second row and first column. If I multiply this second row and first column, I should write 3 into 3, 9. P21 is equal to 5 into 5, 25, and 6 into 2, 12. And last but the least is P22, that is second row. P22 means second row and second column here. So 3 into 2, 6, then 5 into 3, 15, and then 6 into 6, 36. And in this way, we can, if I add this, I will get the result. That is 25 plus 6, 31. Here I get 37 plus 9, that is 46. Here I can get 39 plus 4, 43. And here I can get 36 plus 5, 41, 51 and 57. So, the final result of the AB matrix or this product matrix, I should write as AB, here is equal to, you can write 31, then 43, then 46 and 57. And you see that its order is 2 into 2. You must write the order always whenever you are expressing any matrix. In this way, finally, we learn the matrix product. You see this video repeatedly, you can also multiply by 3 by 3 also. I am showing you another product for 3 by 3 matrix because that is also important for square matrix. Suppose a matrix 1, 0, 2, 2, 3, minus 1, 2, 3, 3, 1. If I want to multiply this 0, 2, 3, minus 1, 2, 3, 1, 0, 0. Suppose I want to multiply this, and since it is a 3 by 3 matrix and it is also a 3 by 3 matrix, definitely this product result also will be 3 by 3 matrix. Naturally, the end result should be what? P11, P12, P13, P21, P22, P23, P31, P32, P33. So write the scheme of the product result. This will help you. You will never forget. Now if I multiply this, here 1 into 0, 0, 0 into minus 1, 0, always write plus, always add this, plus 2 into 1, 2. This is your P11. Next is P12, first and second column. So 1 into 2, 2, plus 0 into 2, 0, plus 2 into 0, 0. So this is my P12, P12. Next is P13. P13 matlab first row and third column. So 1 into 3, 3, plus 0 into 3, 0, plus 2 into 0, 0. So in this way you can get P13. Then 3 into P21, second row and second row and first column. So second row and first column, 3 into 0, 0, minus 1, plus 1, plus 2 into 1, plus 2. What is P2? See the scheme, P22. Second row and second column, 3 into 2, 6. Then minus 1 into 2, minus 2. Then 2 into 0, 0. Then P2 3, second row and third column, 3 into 3 9, then 3 into 3 9, then then second row third column, then 2 into 0 0. Now P31, third row first column, 3 into 0 0, then 3 into -1 -3, and 1 into 1 plus 1. P32 is equal to what? Third row and second column. So 3 into 2, 6. 3 into 2 again 6. You have to add plus 1 into 0, 0. And last but the least, P33, that is third row, third column. 3 into 3 9 plus 3 into 3 9 plus 1 into 0 0. And in this way, we can say therefore suppose it is A matrix, it is B matrix. So AB matrix should be written as, if I multiply these 0 0 0, add 2, this is also 2, this is 3, here it is 3, here it is 6 minus 2 4, here it is 18, here it is minus 2, here it is 12, and here it is 18. And finally you can get the result and you get the order of the matrix is 3. That's all the product of the matrix. Next, in my next episode, next class, I will teach you the properties of matrix. Thank you very much.